subject for today is recursion. So when you Google recursion, Google joking about that and ask you maybe you mean recursion, and you click that recursion and you get again this advice, maybe you mean recursion. So what is recursion? Recursion, if we answer this question in a very simple syntax programming way, this is the method which calls itself. This is the method which calls itself. So recursion, it is something which we could meet in this world in different places, you know. So it is also possible in terms of language. So for example, we have interesting definition of one of web development languages, PHP. Definition of that is PHP for P letter, hypertext preprocessor. So we see these two letters. It is kind of okay, good explanation, but what about that? What is PHP? PHP is PHP hypertext preprocessor. So it is recursive definition used in language, despite it is about programming languages, but it is play, it is game, you know, in actually just language science, linguistics.
GNU is not Unix.
So yeah, so again, here we could just do it by ourselves. So I would like, okay, I will program on my whiteboard. Then, so for example, we have method, and so call it something, I will call this method func. Yeah, hopefully I will show it soon on our screen. So func, and okay, let it be empty method, okay, public static func, and I do something here, and then I again call func. So this is it. This is recursion. I have function, and inside this function I call the same function. So by the way, if you search for example, I don't know, if you know what is fractals. Do you know what is fractals?
A recursive function.
It is something very beautiful, which is just mathematical. Do you see this picture? The idea is that some image could be, okay, for example, this is kind of fractal. Something could be repeated many times, and this is kind of image of what recursion is. Or, for example, when you talk with somebody in Google Meet or Zoom, and you're sharing your screen, and in that screen you're showing your actual Zoom screen. You saw that?
Yeah.
You try that? So it is also recursion, kind of recursion. So it is infinite replication of something many times. Okay, so my idea is to show you how to program that. Okay, recursion, one method call itself. So that's why I need some method. I will create this method. Public static. Let it be void, as I said, func, like function. And in this function, okay, I will output something, but I will call this function. So I have function, and when I run this function, I will get something interesting. So let us think about this construction. I have this function. I call this function from outer world, from main. What will I get? Okay, let me output something. Function call. So what do you think? What will I get in this program which we see on the screens?
A lot of fun calls and then a problem.
Yeah, a lot of fun calls. Actually, infinite fun calls, and we will have problem. Yeah, Sam, do you have something to add?
Stack Overflow.
Stack Overflow. This is exactly word I would like to make you familiar today. Do you know Stack Overflow website?
Yeah.
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 Okay, this is times when maybe Stack Overflow become ancient and ChatGPT become more modern, but nevertheless, many programmers use this Stack Overflow website. But idea of this Stack Overflow brand name exactly from the subject which we're talking about. So if I run this program, I will run it, I will get this Stack Overflow problem. Okay, quite many, and at the end, exception and read main, Stack Overflow error. Stack Overflow error. We have some stack and we have error in the stack. So let's make more experiments here. So for example, I have static integer variable I, and I would like increment this I every time I call my function, and I will output call number, and I will put I value here and make some formatting. And let me call it one more time. So you see the idea. Okay, I will delete this command. I have I integer variable, and I increment this variable each time I run func, and I will output this I into console. Run it. Get Stack Overflow error. And actually we could calculate or see how many times we able to run, oh my, this function, this method. So call number 50453, this is our finish call. So we was able, in my computer, I was able to call my function this amount of times. And then my computer said, stop, enough. I can't do anything with that. My stack is overflowed now. Okay, so this is the main problem when we use recursion. This is to get Stack Overflow problem. In a few moments I will describe you what that means, but let's add something to this function to have actually stop, not to have infinite function calls, but stop somewhere. This is the same when we use loops. You remember that loop also could be infinite. And this is kind of very similar to loops. We just repeat some portion of code many times. So we of course should have some condition to stop this function call, or to stop loop. So for example, I would like to have 100 times to run this function. If I less than 100, then run func again. Otherwise, I will not run this func again. So we call this base case. Base case in recursion. When we stop running function again. We should have some condition to stop doing. Okay, let me run it again. And let's see. So I have 100. I run this 100 times. I have no any Stack Overflow problem now because it is not infinite now. It is concrete specific amount of operations. So welcome, we just wrote some recursion. So recursion is very, very useful stuff. So for example, classical example for recursion is factorial. So when we say that factorial of 5, what does that mean?
5 times 4 times 3. 4.
Yeah.
4.
4, yeah, I forgot 4, so I'm programmer, I'm not a mathematician. Okay. This is it. But when we try to think about that like in programming and like about the function, what the idea? Okay, 5 factorial equals 5 multiply. How could we present that?
5 minus
4
1.
factorial.
Minus 1, minus 1, minus 1.
5 minus 1 factorial. What about that? This is exactly recursion. Because we have this mark here. We asking what definition of this exclamation mark in mathematics? And we say this is the definition. But we still don't understand it. Yeah, it's your problem. So this is exactly what recursion is. 5 times. Okay, so if we have function factorial in our program, yeah, and we have some value put here, we could return this value multiply to what? Tell me.
Value minus 1. Factorial.
Again, this function or method, factorial, and put n minus 1 here. Yes?
Mm-hmm.
Will we have Stack Overflow in this method?
Mm-hmm.
Why? Do we have base case?
Yes, we will.
We will, because it is all we have in this function. We never stop.
Okay, then we write something else.
We come to 0, then we minus 1, minus 2, and okay, never stop. We should add base case. Case when we stop calling ourselves. Okay, what are your ideas? When should we stop?
When reaching 0, it should return 1.
When reaching 0. Okay, so if n equals 0, factorial of 0 what? 1. This is mathematics. So we just return 1, and this is it, and do nothing. This is our base case. If we have n equals 0, then we will not call factorial again. We will just stop and just output 1. Yeah? I agree.
Okay, but how do we know the result?
How do we know what?
The result if 1 is returned.
One more time.
Like, oh, I just don't really understand right now. How do we know the result of the factorial in the end?
Ah, yeah.
Yeah.
Good question. Exactly. How do we know the overall result of this stuff? Of course. So we have in our main somewhere, well, let it be here, we have main method. And somewhere in our main method, we just call, we have some variable a, and we would like to have factorial here. So factorial 5.
Yeah, and output is
Let's analyze this tricky stuff here. So, first call, let me put it here. First call of our function, we have f, I will call my function f, f5. So we come to this call, to this line. We put 5 here, okay? Now, we come to this condition, 5 equals 0. No, so we will not run this return, we will not return here, correct? Okay, move forward, return, but before we return, we have this interesting expression. So, n is equal 5 at this point, and then we call 5 multiply factorial 5 minus 1, 4. Oh, okay. So that means we still not return anything. We still calculate result of this new function call. Before we return, before we get any value from this function, we should calculate f of 4. And when we calculate that, we will return this value here, and we'll make this expression, and we will know what to put here in this box. We will multiply that and return. Yes, Alina.
Okay, if I want to clarify for me all this process, can I somehow like input all this stuff in Excel?
Yeah, of course, you could, for example, output here println current value of our factorial, or println current n. I suppose that will be really helpful. That absolutely makes sense. Yeah. So, actually, let's move forward. We stuck here, but we call another function, the same function with value of 4. Okay, we again come here. Now we kind of remember this. You should understand. We remember, oh, yeah, I should calculate this expression, but I should wait because I need to know this result, okay? We just put it, wait please, remember your state, I will back in a few moments, okay? It is the same, like you make homework, for example, your assignment, then you get, I don't know, Telegram message or Instagram message, and you, oh, wait a minute, and you trying to answer this message, and you have your mom call you, and you just, oh, stop, and you, oh yeah, hello, yeah, I will be home at, I don't know, I make my home duties, and you just, so it is your recursion, it is your multitasking, you make this work, but wait a minute, this work, wait a minute, this work, finish this, come back to this, or message, Telegram, or Instagram message, and then finally come back to your home assignment, and I don't know, at night or at 12 o'clock. So this is sort of the same stuff here. This function is not finished yet, okay? This task, our computer is multitasking. It is not finished yet, but we already should know what is factorial of 4. So we come here, 4 equals 0, no. Then before we return, we calculate 4 multiply to factorial 4 minus 1, so 3. And again, you should stop here because you want to return something, but you don't know what exactly in this box. And you again call this function, but with another parameter, correct? So we again have this function call factorial 3. And again, we move here. We compare 3 not equal to 0. And again, 3 times factorial of 2 now, correct? So again, 3 multiplied to something unknown, but we call of 2, and again the same 2 multiplied to something unknown, and call function from 1, again 1 multiplied to something unknown, and then call factorial of 0. Now it is become interesting. 0 here. If 0 equals 0, yes, finally, we reach our base case, correct? Return 1. Okay, now we return 1 here. Now we know 1 times 1. What is the result of that? 1. So we put 1 here. Now we know. So we come back to our previous functions. Do you see that? All of that multitasking was open for our computer. And we just finishing task by task. We come back to the very first function call. 1 multiplied 2. What is the result?
2.
So we put 2 here. 2 multiplied 3, we have 6 here, so we put 6. We come back, you should understand, we come back here and we put already result like 6 multiplied, or yeah, to 4. And then we come back, and come back. So 6, so here we have how much? 24. So we return 24 in our very first call of our factorial function. 24 multiplied to 5, I can do it, of course. How much?
120.
120. Yeah, you know, you smart people. It is like in that joke, you know. I already told this joke to you. So when you ask first year students 2 times 2, what the result, and students says 4, of course, and then you ask third year students, and he answer, why should I know all this? I will write a program for that. So this is exactly what happening with programmers. Okay, so this is lyrics. Let's come back, and we have this result, and overall result of this function is this is the result. So this is the idea. Very nice code, I suppose. Very concise, and we have this mathematical stuff done. Yes.
Yeah,
Questions?
I guess we can do this by using just loop. And
Yeah.
why it's more efficient and better than
It is very good question. Many recursive tasks we could implement using just loops, and we should not make this all these recursive calls. We could just implement that in loops. Yeah, we could do that, but also some of this task looks really pretty and much more easier, less code, more concise, more beautiful. So that's why we also could use recursive implementation. So yeah, actually I could run this factorial. I don't know if we need to do that. So basically public static. So pay attention to, we don't have void, but we have integer return value. So that's why I put return value data type. And so if now equal equals 0. By the way, we could a bit optimize this program. For example, I could put one more condition. Why should I call this function again if I have just one? I already could return one and that's it without any additional calls. So let me just make some small additions to this program. And now this is my formula. Factorial n minus 1. Number minus 1. Yeah. Okay, hopefully it will work.
Isn't in this case number equals 0 unreachable?
Yes, but you could call factorial and put 0
Makes
into
sense.
there. So that's why we still need this if statement to make our factorial very correct from mathematical point of view. Okay. Okay, let me play with you with another method. So, for example, I would like to have something like that in my console. Okay. 5, 4, 3, 2, 1, and then some explosion, output something. So I would like to call some function, put 5 there, make recursion calls, and get this console output. This is our idea, and we would like to implement that. So let's try to do that. Okay. Let's create function or method. Explosion. So again, we get some integer value here. Let it be n. And now let's think. Your proposals. What should we type now?
If n equals 0, then but.
Right, so it is good to think, first of all, when you create recursive method, to think about base case, first of all. The case when you stop. Okay, we stop here. So that's why we put this condition. If n equals 0, output something like this. Okay, next.
Oh, we just output the number.
Hmm?
We just need to output the number, basically, which we have now.
Okay, output the number. Let's do it. Like this, right?
Yeah, and then
Sorry, you don't return after one. So
Okay, I waited for this command.
okay.
So before we
Makes sense.
go somewhere, we need to stop our program. Because if we don't stop, our program will continue and we'll have additional calls. So yes, return. Stop operating at this point. Okay. Of course, we could also put else here. It is also possible, and I can delete return, but so just to show you options. Okay, let it be like this. Next, what to do?
And we need to call the function again,
Just call this function
but
N
minus 1.
with
Yeah.
n minus 1. Okay, let's try it. explosion 5. Run. Bless you.
Bless you.
Yeah, wonderful. We have good results. Our task completed. Okay, so one more thing I would like you to show and to explain is how all this happened. How entirely inside the computer this could be implemented, how it actually works. Do you remember we mentioned this go-to operator, which we don't use in any modern languages, yes? So let me tell you this story. Actually, when we compile our programs, our code still linear. We still have all our code which is follow one by one, instruction by instruction. So actually, when you have methods somewhere, it is still in these lines of code. And maybe you have another method, you also could put this in your code. So when you move through your main method, instruction by instruction, and then you have this function call. This function call means that you should jump in your inner representation, in your binary code of your executable program, for example, executable exec model, yeah, in your binary. You should jump here, execute that, and then come back to the next line. Then move forward and so on. That's why go-to looks very like reasonable here. You go to here, to this instruction, and after that you go to back. This is how we actually could implement methods in ancient world. But of course now we don't do that, but under the hood we have something like this. So now imagine you have this different method and then you have different calls inside that method. How all of that would work and why we have Stack Overflow error. This is because we actually have call stack in our programs. Call stack, what that mean? Call stack means following. When you come in your program to some function, method, you or program or our language interpreter or operating system, we put in our call stack information about this method call, about this function call. For example, we put address, this one. We put this address, where should we come back? We put parameters here. What exact parameters do we put into this method? For example, these parameters. We put this information here. And then, for example, we have inside our method, we have another function call. And actually this function call is just, this function is just another function. What should we do? Remember our example. You're working on your assignment. Someone called you. You take the phone. So you multitasking. You put in your stacks that I should come back after this task to this and so on. The same computer does. Oh, I still in this function, but now I call another function. That's why we call into our call stack information about next function. We put parameters information here, we put address, where to back, so we should back here into this line, let's set into this address. And let's say, for example, we call one more function here. What do we do? Again, we put this information into our stack, address. We would like to come back here. and some parameters information and so on. So now we done with this function. We executed that. This function done. What should we do? We take this function from our call stack, we erase that, we take this address and we say computer, hey, come here and continue to execute next lines. Then we finished with this function. We finished with this function and we take out of the stack this function, taking this address and back our computer to this line and say, hey computer, execute all that lines. And then at the very end, we finish with this function and we come back to our main method and we put our pointer here. This is how it works. So at the very end, you have empty call stack. And this is very nice. But if I call my function many times, so for example, now recursion, do you follow my thought?
Yeah, yeah.
Okay. So again, we have these instructions, we have our function, our method. So I call this function, I put in my call stack this function address, where to back, and parameters. Then I come to this function and I meet my function again. What should I do?
Add new call.
New function call, then new function call. Because I come here, I'm back to the same instruction, but with another parameters. With another parameters. I run the same code, I meet again this function call, I add one more with another parameters, and so on. And finally, I get what? Stack overflow problem. Because my call stack will be overwhelmed with this function call. This is what call stack. So I recommend you to read. I actually put some Wikipedia link to your course. So just to keep that in mind, what this call stack means, okay? Any questions? Okay, so now we have that what is on our screen, we have this function. Let me just trace, not this one, yeah? Let me just trace and describe how it works, and then I will ask you to work just a little bit. So, then we have call stack. So we have somewhere our main method, and first we call this explosion with parameter 5. So explosion and parameter 5, and we put address where to come back. Okay, we come to this 5, we compare with 0 now, and we println 5. Okay.
What does the address do?
What is what?
Address do.
Address. So again, let me use now this part of whiteboard. You have your binary code, your executable, yeah, .exe in Windows or something another in different systems. And your function is placed, have this sequence of zeros and ones just here. And this is the address. What is the address? Address is shift from very starting position to this actual byte. So it is just actually some number.
So is this a variable or?
It is just inner representation in our operating system, our computer. We do not manipulate by ourselves with these addresses in Java, but when we create assembler or C++ code, we actually use these pointers, we call them, addresses. And we could use this address to ask computer, hey, go to this address and execute commands on that address. So this is what that means. When we want to come back somewhere, we should remember this address. this is the essence of address here in call stack. Where to come back, okay? Hopefully you understand that. Right, so we output 5, then what do we have? Explosion and -1, explosion 4. We have one more call stack entity. We have 4 here, again address. We come to the same code, to the same address. We come here to the same function, but we use another parameters now. So it's like blank, like new. We have 4 here, we compare with 0. What do we have? Output, right? Output what? Output 4. And then we again call explosion with what parameter? 3. 3, again, output 3. Call another function with parameter 2, output 2. Another call, parameter 1, output 1. Another call, parameter 0. Now we come here and we print ln bum. So we print in our console this explosion. This is done, and now our call stack, yes.
Sorry, if we have 0, so it is don't go to that address.
Yeah, so because we have 0, we output something and we have return. We do not call this function again. That's why we return by this address actually. But tell me please, Alina, this address points where this address points in this executable model? Here, yeah, absolutely. So it points to the same function, to the same, but in previous condition with this parameter. It points here. So that's why at that very end moment, we take it from our back stack and we come back to previous state of our function, to the same code, to the same module, to the same lines of code. We again come here and we just finish because nothing here. You see? We come into this point after we call this previous line. So there is no any lines to execute. We just come out from the function here. Do you see that? It could be a bit tricky. If we output something, another println here, that would be more interesting. But now we have nothing here, so we just come back from do nothing, all right, come back, do nothing, all right, come back, do nothing, do nothing, do nothing, and after all of that backstack entities, we have nothing to do actually, and that's it. So if I put something here and of this method with a parameter and add this parameter and here and parameter, not n-1 but current n parameter, then that could be, you know, a bit more interesting. So let's see. You see the results. First of all, we output all previous stuff, then bam, and then we come from very top, like from first one. So actual, oh, wow, end of this method with parameter 1. Yeah, because and 2 and 3. So it's really tricky stuff. So we come back.
Because 0 just returned them, so.
Yeah, exactly. I just, explosion n-1 and and we return one by one. So even my mind is kind of clouds now. So nevertheless, that's extremely interesting to trace yourself to understand how it works. So this is the very interesting idea of our recursion. Yeah. All right. So, any questions?
Can you show your code a little bit?
Like this?
No, I mean higher. The rest of the code.
Yeah, it is just another methods which we don't use at this moment. We use just explosion to describe all this idea of call stack. Okay. Okay. Actually, we have no much time. Let's try to do something. You have tasks, and we have not much time. So maybe guys, just 10 minutes. So try to do at least first task.